Hello class, today we are taking a look at estimating non-perfect square roots, and we're asked to label our benchmark lower and higher perfect squares, as well as those square roots on our number lines, draw our non-perfect square where it would go on those number lines, and use that to estimate the square root of the non-perfect square, which we can confirm by multiplying. So in question A, we're asked to estimate the square root of 15. Now 15 is obviously not a perfect square. The closest perfect square to 15 is 16, whose square root is 4, and the smaller perfect square compared to 15 is 9, and the square root of 9 is 3. And so we know that our square root of 15 will be between the square root of 9 and the square root of 16. But where? Well, let's think about our 9 to 16 first off. That is a distance of 7. So if we go and add 7 ticks, we're going to be 9, 10, 11, 12, 13, 14, 15, and then 16. And we want those approximately evenly spaced as best we can. So obviously, square root of 15, this would be 10, 11, 12, 13, 14, 15 would be right here. And that's going to help us estimate our square root. Now, the square root of 9 is 3, the square root of 16 is 4, so everything between those is going to be a decimal, like 3.1, 3.2, so on and so forth, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. And so because of where square root of 15 is on my upper number line, I'm going to guess that it's either 3.8 or 3.9. It's going to be pretty close to 4 since 15 is pretty close to 16. So let's do our check. We want to square each of those numbers, which means multiply them by themselves, and we're hoping to get around 15. So 8 times 8 is 64, 8 times 3 is 24, plus 6 is 30. Placeholder 0, 3 times 8 is 24, 3 times 3 is 9, plus 2 is 11. 4 plus 0, 0 plus 4, 3 plus 1, 1 plus nothing, and 2 dots, 2 dots. So 3.8 squared is equal to 14.44. Now 14.44 is pretty close to 15, but it's not within 0.5 of 15. So let's re-guess and check our 3.9, and we're hoping that is closer to 15. So 9 times 9 is 81. 9 times 3 is 27, plus 8 is 35. Placeholder 0. 3 times 9 is 27. 3 times 3 is 9, plus 2 is 11. 1, 12, 5, 1. So we know that 3.9 squared is 15.21. So our question is, which one of these is closer to 15? Well, this one's only off by 0.21. This one's off by 0.56. So 3.9 is closer to 15, or 3.9 squared is closer to 15. So our square root of 15 is approximately 3.9 is our best guess. Okay, we can do that same process for all of our questions. Look for your perfect squares, place your non-perfect square around those, and then use that to guess your decimal. So let's take a look at question B. In question B, we have the square root of 105. So we want to think about which perfect squares from our memorized list are around 105. I know that square root of 100 is 10, so 100 is a perfect square of 10. And then the next largest perfect square is 121, which is the square of 11. So again, I know my number here is going to be between 10 and 11, and I know that it would be like 10.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 11 would be my next whole number there. So let's think about where 105 would go. Now we don't necessarily need to lay out ticks, but we can think about distance. For square root 105, it's only a distance of 5 away from 100, but it's a distance of 16 away from 121. So obviously it's closer to 100 than it is to 121. And in fact, it's about a quarter of the way. 5 out of 21 is about a quarter. So my guess is going to be something like 0.2 or 0.3. I guess I haven't drawn that perfectly there. Obviously about a quarter of the way through my decimals. So I'm going to guess either 10.2 or 10.3. So let's multiply those out to check. 10.2 times 10.2. 2 times 2 is 4, times 0 is 0, times 1 is 2. placeholder 0, 0, 0, 0. 2 placeholder zeros for that next place over. 1 times 2, 1 times 0, 1 times 1. 4, 0, 4, 0, 1. 2 digits of dots, 2 digits of dots. So 10.2 squared is equal to 104.04. That's pretty close to 105, but it's not exactly 105. So let's check our 10.3. And let's see if that is any closer to 105. I'm just going to move that over a bit for the sake of space. So we got 3 times 3 is 9. 3 times 0, 3 times 1. Placeholder 0, 0, 0, 0. Placeholder 0. 1 times 3, 1 times 0, 1 times 1. So we get 90601. So this one is off by 1.09. This one is off by less than 1. So 10.2 is our better guess. Neither is within 0.5 of our desired number. With larger values like this, that's pretty common. So our best guess is that 10.2 is going to be our square root of 105. And we can continue this process for all of our questions. So again, if we take a look at square root of 50, the square root that is smaller than 50 is 49, whose square root is 7. Next biggest one is 64, whose square root is 8. Obviously, square root of 50 is going to be right in close to 49. So we're going to guess 7.1. It might even just be 7 as the closest. And again, we're guessing 7.1 since we're right up close to 49, whose square root is 7.0. So let's check that. We're going to do 7.1 times 7.1. 1 times 1, 1 times 7, placeholder 0, 7 times 1, 7 times 7. Add. We get 50.41. And that is within 0.5 of our 50. Obviously, 7 times 7 is 49, which is 1 away from 50. So that is going to be our best guess. That square root of 50 is just 7.1. Okay, so working your way through, you just want to follow that process. First off, identify your perfect squares and their square roots. You know that your estimate is going to be between those two square roots, those whole numbers. So in this case, between 7 and 8 is going to be 7 point something. Based on how close you are to each perfect square, take a guess. If you're closer to this end, you'll be 0.1, 0.2. If you're closer to the other end, you'll be like 0.9, 0.8, so on and so forth. And then check your guess by multiplying. Square our number to see if it does in fact give us the original number that we are estimating. And so you can continue that through all of the other questions. I hope that has helped you with understanding how to estimate square roots of non-perfect squares.